Welcome to Southern Maryland Audubon's presentation of the Mysteries and Marvels of Bird Migration with Chris Eberly. I'm Molly Moore. I'm president of Southern Maryland Audubon. So Southern Maryland Audubon offers monthly programs on birds, wildlife, and native plant gardening throughout most of the year, except for the summer. They're always free and open to the public. You don't have to be a member to participate, but we always appreciate your membership and your donations to support our work, supporting birds and their habitat here in Southern Maryland. So our speaker tonight, Chris Eberly, has had an amazing trajectory in the bird world. Just after earning a master's degree in natural resources and ornithology from the University of Georgia, he became the first coordinator of the Department of Defense's Bird Conservation Program, DoD Partners in Flight Program. He held that position for 17 years. He then served as executive director of the Gulf Coast Bird Observatory in Texas, then returned to Maryland as executive director of the Maryland Bird Conservation Partnership. He recently became director of programs with the Interfaith Partners for the Chesapeake. And in his spare time, what little he has, he works to connect people to birds through Bird City, Maryland, the Maryland Bald Eagle Nest Monitoring Program, and the Farmland Raptor Program. There's nobody more qualified to share with us examples of amazing bird migrations from raptors to shorebirds to songbirds than Chris. So Chris, I turn it over to you.
All right, thank you very much for that wonderful introduction. Yeah, there might be some people a little more qualified than me, but I'll go with that. It's a pleasure to be here tonight. Let me get this screen going and make sure we got the right one. All right, Molly, how does that look?
You're all good. It looks perfect.
Okay, super. Well, thanks again for having me here. It's just always a thrill for me to talk about birds and bird migration. It's just one of my favorite things. And you know, after many years, birds still just amaze me at what they do. And every year we're finding out more and more, and we'll find out some of that this evening. So tonight I want to just show you how bird scientists or ornithologists are unlocking the mysteries of migration. And then I'm going to show you some of the marvels of bird migration and just talk about some of my personal migration champions. A little background on Maryland's bird life. There are 455 bird species that have been recorded in the state. I think that's still current. 206 of these, as of the last breeding bird atlas, were known to breed here. I think that number may go up a little bit now with this current atlas. 143 species are considered to be in greatest conservation need. In other words, they need some kind of human assistance to reverse population declines. And we have both resident and migrant species, and migrants are both short distance and long distance migrants. And just one regulatory note from the perspective of the Migratory Bird Treaty Act, all of these species are considered migratory birds. So when you hear people talk about migratory birds in the regulatory sense, I think it's about 1,029 species now in North America. So pretty much all of our resident and migrating species. So a lot of these species you probably see frequently. These are just a few of our year-round resident bird species. A lot of these are just charismatic, some in very different ways than others, from the barred owl down to that little white-breasted nuthatch, which just has a lot of chutzpah, I guess you might say. And then we also have many species that are only here during certain times of the year, specifically the breeding season. And these are long distance migrants, or also known as Nearctic neotropical migrants. They breed in the Nearctic region, which includes Maryland, but then spend 8 to 9 months in the neotropical region, which would mostly for our birds be Latin America and the Caribbean. So let me just talk about some of this terminology and geography a little bit. So in terms of migration, exactly what is migration? Migration, simply put, is just the seasonal movement of birds that occurs to allow them to access ample food resources, generally between breeding and non-breeding locations. There are several kinds of migrations that we can talk about. There's short distance, generally within the US and Canada. There's long distance, which we also call Nearctic neotropical, and those are areas between here in the breeding area and the tropics for the non-breeding area. And then there are a few species that go up and down mountain slopes in something called altitudinal migration. So let me just delve a little bit into what does the Nearctic and neotropical region constitute. So biologically speaking, the world is separated into these different zoogeographical regions. The old world, or paleo meaning old, is roughly the same as what we would call the Eastern Hemisphere. The new world, or the neo, is pretty much then the Western Hemisphere. The Arctic regions are generally considered to be north of the Tropic of Cancer, and it includes the Nearctic and the Palearctic region. Sometimes also this area is called the temperate zone. And the whole Arctic region combines these two, the Nearctic and Palearctic regions. Whole, H-O-L, meaning entire, or whole, W-H-O-L-E. The tropical regions are everything south of the Tropic of Cancer, just in a general sense, and include Neotropical, Afrotropical, Oriental, and Australian regions. As you might guess, these are called collectively the holotropical region. And the world's tropical areas are generally between Tropics of Cancer and Capricorn, although regions south of the Tropic of Capricorn are still considered to be part of the holotropics. So there's our Geography 101 for the day. Bird species around the entire world engage in some very long distance migration. As you can see from this map, this is just a few of the species that have some of the perhaps longest or best known migrations of different bird species. Looking at North American's avifauna, about 2/3 of all North American bird species are considered to be long distance migrants. Things like we see on here, the Arctic tern, Swainson's hawk, are two that are shown on this map. Biomes are groups of ecosystems that have the same climate and dominant communities, pretty much dominant plant communities. When we look at migration patterns, it can help to understand what biomes birds are traveling between. The boreal forest in that real dark green at the north part of this map is also called the taiga. It's the world's largest forest biome. Yeah, it's even larger than the Amazon rainforest. Most of the long distance migrants in eastern North America and across the boreal forest spend their non-breeding months from southern Mexico to the northern parts of South America and in the Caribbean in forested habitats. So they move from one forested area to another. However, most of the long distance migrants that breed in the West migrate to western Mexico and the Pacific slope of South America. So there's different geography in where these birds go. So you might wonder, birds that we get coming here just in the wintertime, where do they predominantly come from? And for the most part, they're coming from the boreal forest of Canada, Alberta, Saskatchewan, up in the central prairie region. So a lot of these are some of the wintering sparrows, and then up in the boreal forest with other species. And these short distance migrants, and here are a few more of them, are still here for the most part. They're itching to leave probably pretty soon. So I'm sure you have seen most, if not all of these. Hopefully you get those regularly most winters. In terms of these long distance migrants that we have breeding in our area, where they go in the winter time is generally to the Caribbean, Central America, and Northeast South America, especially along the Andes Mountains. And again, looking at long distance migrants that breed in the Western United States, interestingly, their ranges don't really overlap that much. These birds generally will migrate to western parts of Mexico and Central America. And I think if I were to give a talk on the evolution of migration strategies, that would be a whole nother hour. So we'll save that for perhaps another time. So as one example, the cerulean warbler is a long distance migrant that breeds in parts of Maryland. The annual cycle diagram here shows when and how long each period of the bird's year is spent. So you can see that blue is the non-breeding season, which constitutes well over half of its annual cycle. The red is pretty much when that bird is up around here in the breeding season. So it, like most warblers, tanagers, orioles, and thrushes, will spend maybe 2 to 3 months on the breeding grounds each year. Then after they're done with their nesting cycle, they will spend about a month migrating to their Latin America wintering grounds. And there they will spend the next maybe 7 to 9 months. That's 2/3 to possibly even 3/4 of the year that they're spending in the neotropical region. And to complete their annual cycle, then they will migrate back, taking about a month to migrate back to the breeding grounds in the spring. So there's ongoing discussions, especially if you have traveled to Latin America to do any bird watching. Whose birds are these? Are they our birds, or are their birds just visiting us for a couple of months? That's an interesting discussion to get into on a trip like that, and I would encourage you to do that. So how do we know where birds go when they're migrating? This has just been one of those questions that has fascinated humans for many, many years. Fortunately, we've got a growing set of tools and technologies that are helping us learn and better understand every year where birds go during migration. Things like weather radar, flight call monitoring when these birds are migrating at night. And then we can do tracking by way of satellites, geolocators, radio telemetry, and then looking at stable isotopes that we get information by taking toenail clippings or feather samples. And then we can do various types of banding or wing tags for visual observations. So I'm going to go through a few of these different technologies. Radar basically is an acronym for radio detection and ranging. Radio detection, RAD, and ranging, AR. Radars basically do two things. They emit a signal and they listen for signals coming back. Birds were first detected on radars during World War II and were dubbed angels because the radio operators really couldn't explain them at first. The first weather radar was in the US was the WSR-57 weather surveillance radar that was implemented in 1957. This WSR-57 gave only coarse reflectivity data. It provided no data on velocity of what was being returned. This image here is one of the last images that was put out by the Miami WSR-57 unit before Hurricane Andrew pretty much wiped it out. After the WSR-57, the WSR-74 came next. It really had no significant technological changes, but it was much more reliable than the 57. After that came WSR-88D, again, implemented in 1988, and the D stands for Doppler. This was also called NEXRAD, for Next Generation Radar. Adding the Doppler allowed these NEXRAD systems to determine the time taken for waves to return to their sensor and detect the incredibly small changes in the frequency of that returned wave. And using these two pieces of information, NEXRAD is able to determine where objects are and at what speed these objects are moving relative to the radar site. In other words, NEXRAD can detect the velocity and the direction of what is being reflected. So WSR-88D essentially ushered in an era that created a new branch of bird study that today we call radar ornithology. In 2013, NOAA, the National Oceanic and Atmospheric Administration, deployed a new feature to its US radars called dual polarization, or dual pol for short. These are pulses of microwaves emitted at 2 angles instead of just 1. So radars outfitted with this dual pol allow for better discrimination of targets. Now for meteorologists, their big benefit of that was that these dual pol data provided the ability to distinguish partially frozen sleet from droplets of rain. So for weather forecasting, that was incredibly significant. For ornithologists, this allows us to more easily separate birds from precipitation and other flying creatures that are picked up on these radars, such as moths or other insects. This is a static image of basically a composite of all the NEXRAD systems, the WSR-88D systems, in the fall of 1998. And this was very early on in the lifespan of radar ornithology, and images like this really were groundbreaking. And what you can see in this is sort of in the east there, going from the Great Lakes down to the Gulf, is a line of storms, which I think is a typical type of thing that you will see on weather forecasts and weather reports nowadays. What you see primarily to the west of that in the Midwestern region are these blue circles going from light blue to dark blue and even getting into some of the green. Those are flocks of migrating birds lifting off and lifting up into the atmosphere and hitting the radar beam. So this is something that really was eye-opening to help explain a little bit what these things were. And a lot of times weather reports that you see on TV, I think they probably still do, but historically they filtered out those blue signals, which is a lower reflectivity. So you would never really see a lot of those blue images. But when you get these huge flocks lifting up, like over there in the Midwest, you'd see some of the green. And you can see on the right of this image just kind of what a typical view of precipitation looks like. It's sort of a linear feature, and then the typical view of birds is more of this oval or circular pattern. So this image is from the Lake Charles, Louisiana radar in the spring. And this first image here shows the base reflectivity. So what we can see is a heavy cluster with that dark red. We can see a heavy cluster of objects in the atmosphere that appear to be close to the coast. But now what we can do with this WSR88D, we can also look at base velocity to get a much better picture of what's going on. So green, you can see the center of the circle is where the radar is. Green indicates targets moving toward the radar. Red is moving away from the radar. So what we can see here is a lot coming off of the Gulf, but then not going much further beyond the coast. And what we're looking at here are flocks of trans-Gulf migrants making landfall along the Louisiana coast after crossing the Gulf of Mexico. And generally, they're going to be setting down at the nearest available habitat after flying all night for the most part. So they will not generally, unless they have very favorable wind conditions, they're going to be setting down as soon as they possibly can, which is why we see images like this rather frequently in spring migration. And here's another image showing spring migration in May of 2005. And what this image shows is a strong line of storms that is actually heading southeast toward the coast near Houston, and a large incoming migration of birds heading northwest toward the coast. And if you see this yellow star that's sort of pulsating now, that is High Island, Texas. High Island is just known as a magnet for bird migration and for fallouts in the spring. And if you saw the movie The Big Year, they showed one of these fallouts in a way that doesn't really happen, but the aftermath of what they were showing birds everywhere on the trees and all over is very true. I was there fortunate enough to be there one year when one of these fallouts happened. And I think it was the first time I ever saw a cerulean warbler, and I could have probably reached out and grabbed it off of this branch that was just right there. All these birds are just fatigued coming across the coast, and they're going to put down at the first place that they can that has any kind of shelter or food. So this image is showing a line of storms. You can see that moving off the coast. That's sort of the beginning of the cycle right there. So a line of storms moving off the coast in the fall. And then behind that, you see all these blue circles. They get a little bigger, and then you can kind of see how it's moving to the southeast. So that's a typical fall migration pattern. Line of storms coming through, getting a favorable north wind, and birds are going to take advantage of that and head south. Moon watching and FLIR, forward-looking infrared radar, allowed ground truthing to estimate how many birds are in some of these different intensities of the radar returns, like this intense red block here. So this was measured in number of birds per mile of front per hour, which led to calculations of number of birds per cubic mile. All that really doesn't mean a whole lot unless you can put it into some other graphic form or something else. But basically, and we'll see some of that here coming up. So it was really helping identify, how many birds are in these different, so a dark red versus a lighter red, give us an idea of how big these flocks are coming across. And so while we can see this relative migration traffic rate of birds, it still did not really allow us to identify what species are coming across. And yeah, we're not quite there yet. That'll be one of the next big things coming down the road, I hope. But in the meantime, I hope a lot of you have discovered Birdcast, something that was developed primarily through the Cornell Lab of Ornithology. Birdcast has taken a lot of this information from radars including this density and number of, birds per cubic mile, and basically merged it with weather forecasting. So now what we really have at our disposal, you could call it bird migration forecasting, which is what Birdcast essentially is doing. And this is just one image from a few years ago in May, showing the relative intensity. Those real light yellow, almost white colors are the highest migration traffic rates, going down to the blues, which are very low. And then the direction, the arrows showing what direction all these migrant flocks are going to be moving. And Birdcast has evolved to where not only it can show the estimated number of birds, but now, as you can see on this, you can pull up a screen that will show the previous evening what happened in terms of how high were these birds flying, what direction were they going, and what speed were they flying in various different forms and graphs. And then on the right there, you can see sort of these seasonal bar graphs of what would be the expected nocturnal migrants. Now, this is just based on eBird. So kind of aligning the Birdcast forecasting with eBird recording sightings on the ground to sort of give that. This is not the actual, well, these are the exact birds that were here. But at least we are now getting to the point where we can have a really good idea of most likely what was moving through the atmosphere on any given night during migration. So Birdcast shows this sort of national forecast of migration, and you can go on there now and see, and tonight around here, it's pretty bleak, low. I just pulled this off today just to show you what things are happening tonight. Not much, 0 to 7,000 birds per kilometer per night. So it's a low migration. However, you want to keep an eye out to get these alerts. And this is taken, this was a couple years ago, taken in Brownsville, Texas. The conditions were just right, and they were anticipating more than 31,000 birds per kilometer overnight. And the next few nights, the migration forecast was high. There was going to be a lot of birds moving through. So this is a great tool to know when you can expect that there's going to be a lot of nocturnal migration by warblers, thrushes, tanagers, and the like. And then you can go out and you can listen for nocturnal flight calls. Most of these songbirds give unique call notes during their nighttime migrations. And this is showing just some homemade flight call recording information or equipment that you can relatively easily put together yourself using buckets, ceramic planters, dinner plate, plastic wrap, a microphone, and then a link down to your computer. And what this hopefully then will do, if you're getting good migration, is record the acoustic signature of one of these individual call notes. And you can see on that white graph, it's time by frequency. And this is 100 milliseconds. So that's 1/10 of a second showing right there. It's just a very, very short little call note. And just a couple of species down below there showing what those look like. So recording these nighttime flight calls can be fun. It can give you species specific data and gives you the ability to detect some of these species that are rather secretive that you might not see during the migration period. Disadvantages, though, are detectability of different species groups can be hard if there's a lot of them. It's hard to get an estimate of how many numbers of birds were there, and these things, recording all this data and storing it does generate a lot of data. but you don't have to save it unless you're one of those diehards. And this is something that the Cornell lab put out a few years ago that they call the Rosetta Stone to the warblers. These are basically the call notes, the acoustic signatures of the call notes of all the warblers that occur in North America. So this science has really progressed to the point now that we can see exactly what each of these warbler species acoustic signature looks like. And then if you have an app like Merlin, the sound ID component of Merlin has gotten, I'd say, really good. It's not perfect yet, but it is really, really good. And to the point that it can even pick up some of these call notes. So if you have your cell phone, go out there during one of these big migration nights, turn on the Merlin Sound ID thing, and you may not pick up as much as something with a microphone on it, but I think you'll be surprised at what Merlin will be able to tell you is flying overhead. So moving on to some of these other aspects of unraveling the mysteries of migration. Stable isotopes are a way to help us see where birds have come from. So looking at the isotopic signature of birds is you can take a toenail clipping or a feather, and feathers of most of the warblers are molted and regrown as soon as the birds arrive on the breeding grounds. So feather samples taken on the wintering grounds would have the isotopic signature of where that bird grew the feathers. So when the bird just gets there to the breeding grounds, you can sort of pluck that feather maybe and take it out and find out where that bird came from. Conversely, birds between the breeding and the wintering grounds, you can do the same thing. So this was really Dr. Pete Mara, who at the time was with the Smithsonian Migratory Bird Center, really did a lot of the pioneering work on this and what he calls migratory connectivity, which is the geographic linking of individuals or populations between different stages of the annual cycle, such as between breeding, migration, and winter. So what this has is tremendous significant implications for conservation, that now we can study population vulnerability and the dynamics of subpopulations rather than just populations as a whole. And I just want to point out here that these are, he studied American redstart. And so the similar colored circles with the arrows between them show areas where subpopulations of American redstarts will breed and spend the non-breeding months. And these subpopulations go back and forth between these two areas. So when you see a range map like what's behind this, you see that whole area of red, which is sort of the breeding area. Well, that, you know, in the past we thought all of these birds just come up here and mix around. Well, what we know now is that that big red area is made up of a lot of these different subpopulations that have a lot of site fidelity to smaller geographic areas. So in the 1990s, ornithologists uncovered what was at the time what they called the holy grail of migration tracking. Well, throwback to a time before the 90s, maybe. It was not that holy grail, but it was being able to track birds by satellite from the comfort of your home or office without having to go out in the field. So Brian Woodbridge here, shown on the right, at the time with the U.S. Forest Service, was studying Swainson's hawks for about a decade out in the West, and noticed the number of returning hawks was lower than the number that departed in some years, sometimes significantly, sometimes adults were lower, sometimes juveniles were lower. At the time, we just kind of knew they headed south, down into South America, but didn't know exactly where. So way back in 1994, he was able to scrape enough money together to buy 2 of these satellite transmitters and put on 2 of these hawks. One of those transmitters died almost right away, but the second one worked and allowed him to track the birds down to a specific area in the Pampas region of Argentina. And what he found when he went down there turned out to go from a disaster to a huge conservation success story. So this was a time when we now know that these birds primarily feed on grasshoppers in the non-breeding season when they're in Argentina, quite different than their diet in the breeding season. So when these grasshopper outbreaks happened, the local farmers would spray a pesticide that would kill the grasshoppers, but also then ended up killing the birds. A lot of conservationists got involved, a lot of discussions with the ranchers who did not want to kill the birds. And once they knew what was going on, they stopped using that pesticide. Pesticide was ultimately pulled off the market. And Swainson's hawk population has rebounded very nicely since that time. Shortly after that, another group at the time called Center for Conservation Research and Technology outfitted more than 30 different hawks. And so this range map on the left is kind of what we might normally see, but now on the right, we had maps of individual points from these 30 different birds that showed exactly where they went and the timing of their migration status. So this really opened the door to better understanding migration and assisting in conservation efforts. This same group started outfitting peregrine falcons with satellite transmitters shortly after that. The first 18 months of getting satellite data provided them with more information than they were able to collect in the previous 25 years just by banding falcons. So this just was a real boon to know where these birds are going, what routes they're taking, and enabled us to sort of see the separation of the two subspecies of these peregrine falcons in the breeding and wintering areas. So the goal and hope for ornithologists is now just really to miniaturize satellite tracking technology so we can fit it on passerines, songbirds. The limiting factor still today is power, but light level geolocators are kind of an interim solution, one of the interim solutions. They've got a light sensor, an internal clock, a battery, and a computer that stores a measurement of the amount of light. So essentially it can detect sunrise and sunset and determine a bird's location to within about 250 miles. So for species like a purple martin, it was enough to help us understand that there are different wintering grounds for Western birds versus the Eastern and Midwest birds. That was something that was previously unknown. We still, with that light sensor, can't narrow it down really closely, but at least it gets us that general area so we know where these segmentations are occurring in the wintering grounds. Another new system that had come along was an automated radio telemetry system that Bird Studies Canada developed called MODIS, which is the Latin word for movement. MODIS towers can detect a species, any species outfitted with one of these little nano tags that goes by the MODIS tower. Recapturing the bird is not required. And this is a map showing the current network of MODIS stations, MODIS towers in the Northeast US. You can see around the Mid-Atlantic region, we're getting an increasing number of stations. There are a few in Southern Maryland. If you may have had a talk, or you may have a talk at some point by Greg Kearns at Patuxent, that he's done some work with SORA and MODIS towers and installed a couple of these towers. This is just a really evolving technology that's really helping. And you can see when this this image shows the detection range, the individual detection range of a station, as opposed to just where the stations are. So you can pretty much see any bird coming from the northeast, heading down the coast, or even through the mid-Atlantic and the Piedmont. If it's got a MODIS tag on it, we have towers out there that are probably going to pick that up. So what this really does, it's been helping us get a better sense for some of these smaller birds, the songbirds. Swainson's thrush and gray cheek thrush are a couple that are fairly commonly tracked, to help us identify if these birds are going around the Gulf of Mexico in their migration or crossing the Gulf of Mexico. So just helping us narrow down a little bit better where these birds go, and helping to unravel some of the conservation conundrums that we seem to face when looking at population declines of birds from the time they leave here to when they come back here the next breeding season. And just an example of some of these birds with these nanotags on, bats. They're put on bats, and they even have tags, these MODIS tags that are small, to put on monarch butterflies. So monarchs, some of these monarchs are now being tracked with MODIS. So saw-whet owls, some of the warbler sparrows. Just a really, really cool thing. And technology just continues to get better, smaller, like all computer stuff, smaller and less expensive and more powerful. So now I just want to finish up by talking about a few of my personal migration champions. And I just picked a few categories: longest annual migration, longest non-stop flight, deepest diver of a long distance migrant, smallest bird that can cross the Gulf of Mexico, most energy efficient, best contribution to science, best coolness factor, and most celestial migration. So to start it off, the winner for smallest bird to cross the Gulf of Mexico, probably not a surprise to many of you, is the ruby-throated hummingbird. So this bird weighs in at a little more than 1/10 of an ounce, which is about the same as a penny. It's about 3 3/4 inches in length, about 5 times the diameter of 1 penny. So in spring migration, this bird will generally take off from the Yucatan Peninsula with many other passerine species and fly 500 to 600 miles nonstop over the Gulf of Mexico. So for such a small bird to be able to do something like that, I think that's still pretty amazing. Hope the Whimbrel gets an award for the best contribution to science. Hope made extraordinary flights over open ocean, encountered several major storms, and along with 24 other tracked birds, revealed important details of Whimbrel migration previously unknown to science. A female Whimbrel, like Hope, weighs just under a pound and is about 1.5 feet in length. Researchers at the Center for Conservation Biology at the College of William and Mary tracked this bird back and forth 4 times between the breeding grounds on the Mackenzie River Delta in Northwest Territories of Canada and her winter territory on Great Pond, which is on St. Croix in the US Virgin Islands. She recorded more than 50,000 miles, with each one-way journey being at least 7,000 miles. And after the solar-powered satellite transmitter failed, Hope was captured in November of 2012 in St. Croix because she would go back to the same place every winter. The transmitter was removed and she was free to continue her amazing journeys. So this was, at that time, the most successful tracking effort of any shorebird. Now, if ever a bird took a chill pill, I think it would have to be the swallowtail kite. And if you've ever seen one, I think you know what I'm talking about. To watch this raptor soar slowly and effortlessly. It's just like to have all your troubles melt away. Kites weigh about a pound, but will bulk up to 19 ounces before starting their fall migration. They're about 2 feet in length, but their total wingspan is twice that. Like seabirds, kites are meant to soar for long periods of time. The Avian Research and Conservation Institute, based out of Florida, has been leading a lot of the research on swallowtail kites. So this map shows the tracks of 8 kites that they tracked with satellite transmitters in one southbound migration. The average distance traveled was more than 5,600 miles. You see the next to last bird on the list, called Slidell, named after a town in Louisiana where it was tagged. It's the red line, traveled more than 45,000 miles over 4 different migration cycles between 2012 and 2016. So for the graceful soaring, its beautiful lines, and the ability to eat on the fly, I give the swallowtail kite the award for the best coolness factor of any long distance migrant. Now the next award goes to the species with the longest non-stop flight without a rest. And the winner is the bar-tailed godwit. So based on new information, this award has been modified to apply just to seabirds and shorebirds, as we'll see just a few moments. So during the breeding season, this bird weighs about 9 ounces or so. It will double or more than double its mass to 19 ounces before undertaking the most extraordinary single flight of any bird. And as most long-distance shorebirds, the godwit's wingspan is nearly twice its length. The longest recorded nonstop flight without rest is by this species. Satellite tracking of this species began in 2007, and the longest recorded flight was by this bird, dubbed E7, based on its band. This E7 took 8 days to travel 7,250 miles from Alaska to New Zealand, averaging about 35 miles an hour. In March, it departed New Zealand, made a stop over a few weeks in China, and then headed to Alaska once again. But in 2020, a new champion emerged. In September that year, another bar-tailed godwit called 4BBRW for blue, blue, red, white, based on its bands, left Alaska and arrived in New Zealand 9 days later, traveling more than 7,500 miles at speeds of up to 55 miles an hour. And you can see here, it looks like some easterly winds pushed the bird to the west before it corrected itself as it passed over New Caledonia and Papua New Guinea. But not to be outdone, this same bird broke its own record the next year when it flew 239 hours nonstop on a journey that covered more than 8,100 miles. That's basically 1 hour short of 10 continuous days of flying without food, water, or rest. However, last fall, this juvenile bar-tailed godwit, B6, set yet another record. The bird left Alaska on October 13 and arrived in Tasmania, Australia on October 24. It flew 11 days without stopping and covered a total of 8,425 miles. I'm just betting that there will be yet another champion come this fall, the way these bar-tailed godwits are advancing things. So during an annual cycle, the bar-tailed godwit covers about 18,000 miles. David Douglas with the U.S. Geological Survey in Alaska said, the bar-tailed godwit can be considered the world's greatest athlete. Well, I'm not sure I'm buying that just yet. For those of you that remember the old Batman series back in the 60s, let's check in with Alfred. What does he say? Yeah, perhaps. Yes, perhaps. Sorry, I just got to throw in some of these flashback things for those of us who remember them. The sooty shearwater is one of the most common seabirds in the world. They breed in these enormous colonies in both the South Pacific and South Atlantic Oceans. Their breeding colonies can exceed 2.5 million pairs. When not breeding, the sooty shearwater embarks on one of the largest mass migrations known. The sooty shearwater weighs 2 to 3 pounds, and in typical seabird fashion, its wingspan is greater than twice its length. These seabirds soar for hours without flapping, and they wander widely over the open oceans. But the sooty stands out in one aspect from other seabirds, in that it can dive regularly to depths of 120 to 130 feet, but at times it can go as deep as 225 feet down to catch its food. So therefore, this bird, I give it the award for deepest diver of a long distance migrant. But as I mentioned before, after breeding, these sooty shearwaters undertake one of the largest mass migrations in the animal world. For birds nesting off New Zealand or Australia, they will traverse the Pacific Ocean in a figure eight on a months-long foraging trip. They'll leave the breeding grounds and will travel east, sometimes to the South American coast, before turning north. And after foraging in the North Pacific from Japan or Alaska and the west coast of the US, it will return to New Zealand to its breeding grounds. This round trip will cover some 39,000 miles each year. There are 6 subspecies of red knot in the world, 2 of which are associated with the Americas. You can see here the Rosalaria and then the Rufa, which we're more commonly familiar with on the East Coast. The Rufa subspecies breeds in the low latitudes of Arctic Canada and winters from the Gulf of Mexico all the way to eastern South America. So this red knot, dubbed B95, again, based on its leg band, is the oldest known Rufa red knot in history. Prior to B95, the oldest was 19 years old, and at the last known sighting, this one was 21 years old. And Rufa red knots are about 1 foot in length and weigh less than 5 ounces. Now, B95 flew between the Arctic breeding grounds and the wintering home at the southern tip of South America, a round trip journey of about 20,000 miles. On the northbound migration, he would fly nonstop for 5,000 miles over 6 days to go from the coast of Brazil to Delaware Bay. And hopefully some of you have seen red knots foraging in the spring in Delaware Bay. This bird made the journey at least 24 times. So being born in 93, was banded in 95, estimated to fly about 20,000 miles a year. In 24 years, at least 480,000 miles. It's 480,000 miles to the moon and back. And so hence, this bird got the nickname of moonbird. And so for this out of the world feat, I hereby bestow upon B95, the moonbird, the award for most celestial migration. But a new champion for the longest annual migration was declared after studies using light level geolocators on Arctic terns. So this one study tracked 11 of these Arctic terns for 1 year, and these birds averaged 44,000 miles round trip in a year. In another study, one Arctic tern traveled amazing 59,600 miles in 1 year, the equivalent of flying around the circumference of the Earth twice, plus an additional 10,000 miles. So Arctic terns can live up to 30 years. If this one bird that flew 59,000 miles lived 30 years, that bird would fly more than 1.8 million miles, enough to go to the moon and back almost 4 times. So of course I had to call this bird El Pájaro de las Cuatro Lunas, the 4 moon bird. Might be a good name for a brew pub. And now the final award, the final award-winning migrant. My personal favorite. The black-polled warbler is a small wood warbler that breeds in the boreal forest of Canada. Weighs about 5.5 inches in length and weighs just under an ounce, about the same as 4 pennies. Blackpolls can fly up to 6,650 miles from Western Canada and Alaska just to get to a staging area of sorts off the New England coast. If we wanted to help this bird, we can mail it from the Yukon Charlie Preserve to the Rachel Carson National Wildlife Refuge. And better yet, we could mail 2 of them for 1 first-class stamp. We really can't do that though. But blackpolls, once they stage off the New England coast, will wait for favorable northwest winds, and then they'll take off out over the Atlantic Ocean. And as crazy as that sound, it works. They continue until they hit the trade winds somewhere near Bermuda, and then they'll redirect themselves toward the South American coast. When they finally make landfall in Venezuela, they will have flown 60 up to maybe 80 hours or longer nonstop, which means at about 20 flaps per second, these birds may have flapped their wings around 3 million times. A car with a gas-burning engine with the same efficiency as a black-polled warbler would get about 720,000 miles per gallon. And if this were a human runner, an avian physiologist studying blackpolls likened this bird's long-distance flight to the medical equivalent of a 160-pound marathon runner averaging 4-minute miles for 70 hours and losing 40 pounds. So that would mean the human equivalent of a black-polled warbler running not just 1 marathon 15 minutes faster than the current world record, but running 40 of them at that pace in a row without stopping. So I want to show you just quickly an animated abundance map. And you can see here, getting up through the middle of the year, they come back up from the wintering grounds or breeding, and you can see how they now start to stage over off New England coast and then disappear and magically appear on the coast of Venezuela or northern South America. So for this feat of unimaginable endurance, being a former marathon runner myself, I give the black-polled warbler the title of most energy efficient creature on the planet. So, like anything, new research shows new results. And while birds don't need the technology to do what they do, technology allows us to uncover migration feats that continue just, I think, to get more impressive. So those of you old enough to remember the on-court exploits of John McEnroe might understand the title of this next award. You cannot be serious. So we already know that swifts are amazing and spend their entire day on the wing. Alpine swifts are an unusually large species in the old world with a wingspan of about 22 inches, which is about 8 inches more than chimney swift. In 2012, ornithologists began studying these birds with trackers and found that that once swifts began migrating south from Switzerland, they crossed the Mediterranean and the Sahara and into West Africa. They did not land for more than 200 days, which is more than 6 months of nonstop flying. But then several years later, a similar study on common swifts, like this one doing its best skimmer impression, would make even John McEnroe proud. So ornithologists discovered that some common swifts spent fully 10 months of the year on the wing in West Africa on their wintering grounds. So a common swift can live 15 to 20 years, which means a total mileage of a common swift during its lifetime might be about 3 million miles. In other words, you cannot be serious. So common swifts can obviously feed on the wing, and they're also practicing what's called unihemispheric sleep. Scott Weidensaul, in his book, A World on the Wing, has this additional insight. What's more, they surpass even the masterfully gliding and soaring frigate birds in extreme energy conservation while aloft. A recent study of common swifts found they glide nearly 75% of the time, and they were so skilled at playing off changes in the airflow and rising thermals and other currents that their overall energy expenditure was not significantly different from zero. In other words, they're not using any energy to do all this flying that they're doing. So the common swift, in my opinion, qualifies for longest nonstop flight, longest annual migration, most energy efficient, and well, you cannot be serious. So that may be now my new favorite bird. I don't know, blackpoll warbler's still there. But I thank you for your attention on this. I just want to close with one note here. I am on what we call the board of directors for the Maryland Osprey and Nature Festival. So as Molly mentioned, Southern Maryland Audubon was just there. And on behalf of Sal Acasa and all of us involved with this festival, I just want to give our sincere thanks for the support of all of you at Southern Maryland Audubon for this worthwhile event. I know Molly was there this past weekend, and Greg Klesch also, who is also on the board of directors for that. So thank you so much for supporting a worthwhile effort like this. Just a quick shout out to some of the photographers whose images I was allowed to use. There's some websites, and I know you're not going to see it here, so I can get this information to Molly. She can make it available in a separate way, I guess. And then also some information on books that I would highly recommend if you are interested in anything I talked about here tonight. And so with that, thank you very much for your attention. Thanks for having me here and allowing me to share my passion for birds and bird migration this evening. So I guess at this point, we can open it up to questions if anybody has any.
Chris, thank you so much. I don't think any of us can look at the migrants coming through again in the same light after listening to your presentation. Just really incredible. Thank you so much.
Glad to do it. Bird migration is just one of those things I'll never stop being amazed at.
So I do have a question.
Yeah.
With all the new technology, what are we learning about how climate change is affecting migration patterns?
Probably one of the biggest changes we're finding from climate change is really the phenology, which is the timing of when birds are leaving one place, arriving in another place. And you know, if you're out birding during spring and fall and all the seasons, I mean, just take, for instance, ospreys. I think, you know, maybe you've noticed that there actually have been a few ospreys hanging around all winter for the last couple of winters. That you know, has not always been the case. We're getting certain other species that hang out here longer and longer in the fall. A few of them maybe are not even leaving as well. So the timing is changing. And over in Europe, they've been studying this phenology thing for many, many more years than we have in the US. And they've noticed this with plants and how that impacts then birds that are coming back earlier, but the plant cycle that they depend on and the insects hatching may not be the same So that whole change in phenology is sort of impacting the whole cycle of nesting and nest success. And sometimes birds are hatching their young before the food is really available for them. So that it's something to keep your eye on. And you know, these are changes that we can see from year to year. If you just get out there, go on these bird walks, and just, you know, take a notice of what you're seeing year after year.
Great, thanks, Chris. We have a couple of good questions here. Linda Barker asked, so are these birds able to make such long flights because of their ability to catch the wind currents?
Short answer, yes. Birds are amazingly adept at knowing where and when these winds are. Now, you know, if you remember back to like the radar ornithology, those slides that I showed, a lot of times the best migration in the fall, and sometimes even the spring, but primarily the fall, when you get these big fronts that come through and the line of storms, and then what happens after that, it's a cold front coming from the north, you get those prevailing winds from the north. That's when you're going to see the peak of migration activity in the fall, is after the passage of a front and you get that favorable wind. And birds will find the right elevation, the right altitude to get the best trailing wind for that. Blackpoll warbler is a good example. When it takes out over, you know, off of the coast of New England, out over the ocean, it's waiting for one of those fronts. They're going to get that prevailing wind, and then they go to where they hit the trade wind, which is the prevailing wind from the north heading to the southeast or southwest, northeast to southwest, to send them back to the coast of South America. Shorebirds, seabirds, well, the bar-tailed godwit, Arctic tern, a lot of what you see on the, especially in the timing, you can really notice it, that each individual track coming from a satellite transmitter, you can see sometimes there's a very short distance between 2 points and sometimes a long point. That's when they're trying to adjust for different wind conditions, and maybe they don't have good winds, but then sometimes they'll get it. And you'll see the long distance between 2 points, which is the same time frame. So they have found that sweet spot, and they'll do that. So anything from songbirds in North America to bar-tailed godwits to falcons to hawks, they know how to catch the wind, and that is a big factor in helping them migrate efficiently.
Thank you. And John Anderson asked, how do the tracking tags that are put on the birds affect their flight or their behavior?
Well, in order to get the authorization, well, first of all, a lot of work is done to look at the physiology of putting something on a bird, and then how to attach it to a bird. Whether you do these loop harnesses around the wing, or some of the smaller ones, they just actually do a little glue. Generally, it's no more than 3 to 5% of the body mass or the weight of the bird. Any more than that, then they've noticed that's when it starts to impact the health of the bird and its performance, its ability to fly efficiently. And that's why satellite transmitters, it's taken so long to just start to get down to smaller and smaller birds, and why we're not yet to that point to be able to put them on a songbird, because it's too heavy. And if it's too heavy, then the bird is not going to be able to fly, or it won't fly at its regular capacity. So there's a lot of attention given to what can be put on what birds and how it is attached. So yeah, a lot of care is taken to make sure that we're not negatively impacting the health of birds.
And Deborah Turnell asked, is light pollution having an impact on night migrating birds?
Yes. In fact, yeah, look at the background behind me. I think this is the one, and it's so I can't read it, but I think this is dim the lights for birds at night. I think that's what it says. It's a little thumbnail, but anyhow, light pollution does impact birds during migration. all these lights out programs, that is one thing that they're focused on. Cell towers, other structures that have lights on them, especially during times of fog and other inclement weather that will disrupt the other cues that birds might be able to use, like the stars, or maybe interfere with the magnetic field detection. They'll focus on the lights. So if they're focusing on the lights, they're being drawn to artificial areas. In other words, areas that really they should not be going to during migration. And interestingly, during migration, cities can actually, you can actually find a lot of migration happening around cities. And that's because of the lights. It doesn't necessarily mean that cities are going to provide the best migration stopover habitat. It's just that the lights are drawing these birds in. So anything that you can do to help spread the word of turning out lights, and not just in big cities, but all over the place during migration. And these peak migration nights that are forecast on Birdcast, those are nights in particular that cities should be turning out lights in tall buildings, that people should be turning out lights in their houses. Don't have lights that go up into the sky. Lights can really cause a problem. Yeah.
And Genevieve asked, are there specific or better times during the night to see the evening migrators?
Well, I guess part of that would depend on where in the migration season we are and what has been going on a previous few nights. So if there's been inclement weather, birds kind of stack up and they're just waiting for these good conditions, like the passage of a front and then the good north winds. I would check that Birdcast. I mean, that's just such a good tool. And you can check like the previous night, if it's a good 2 or 3 day period, and see. Generally, you're going to get the best, probably, I think, as a general rule, within I don't know, 3 to 4 hours after sunset. The birds are going to start to lift off. But it also depends on where, what elevation those prevailing winds are really hitting. If it's a very high up prevailing wind that they're going to go to, it's going to be harder to detect them. If conditions are better lower down. And if you look at those Birdcast charts, you can see throughout any given night, they'll be flying at different altitudes. And that's all because they are finding the optimum prevailing wind that's going to help push them along. Songbird migration generally is nocturnal, so starting within an hour after sunset is going to be when you want to get out there and look. And I think as the night goes on, you're going to get fewer and fewer birds, smaller and smaller groupings of it. So probably like an hour after sunset to midnight, 1 in the morning, I'm guessing is probably going to be your best bet.
And Fawn Palmer asked, has there been a correlation with the ENSO phase for bird migration patterns like El Nino, neutral, La Nina, neutral, El Nino? The jet stream is more sinuous with La Nina. We are in neutral and will be in El Nino by summer.
I haven't really seen a lot of discussion about how La Nina, El Nino, the whole ENSO cycle impacts migration. It seems to have more of an impact on breeding, in that it really it has an impact on precipitation cycles, and that can impact vegetation growth, which then can impact insect outbreaks and things like that. So I think the impact for birds is more just on breeding and potentially overwintering, but probably more the breeding. I don't know that it has a significant impact on migration timing or maybe migration routes to a small extent. but yeah, not as much on migration as it is probably on just potential impact on the nesting cycle.
And one last question from Jen. What is the most important thing eager birders can do, or maybe more importantly, not do, to support birds during migration, particularly around birding hotspots?
Well, the lights are one factor. Making sure that lights are not going to create a situation that are going to draw birds in. Cats are always something I like to encourage people to keep your cat indoors, especially during nesting and then migration. Some of these birds will fly many hours overnight. When they land in the morning, they're going to spend a lot of time focused on refueling and resting. So if it's birds that forage on the ground, like some of these sparrows or even certain warblers and thrushes, they're going to be probably a little more vulnerable to predation because they're focused on just refueling and doing the rest. And if you are out birding, that's one thing. When you the whole thing about pishing doesn't always work during the migration season because birds are focused on something else. They're not worried about these avian predators coming in. So just be aware that they might be a little more vulnerable to predation, not just from cats, but other things as well. Those are probably two of the big things. Yeah.
Well, Chris, this has been absolutely fascinating. Thank you so, so much for sharing this all with us. And I want to thank everybody who came out. This has just been a terrific presentation, and really appreciate all your questions, your participation. And Chris, really appreciate all the effort you put in this presentation, and you're getting tons of kudos in the chat box.
Well, it's just a pleasure for me. And I, as you can tell, I really enjoy talking to people about something like bird migration. And I just want to extend my thanks to all of you out there. Keep on getting out there. The more you get out birding, the more you learn about the birds, the more you can help the birds and educate other people.
Great. Thanks so much, everybody. Have a great night.
Thank you.